Okay. Sir? So you'll notice they gave us this chart, and you're seeing as potential answers some a way of seeing the answers that you guys have not seen before. I've never given you the cosine of an angle left in there like that. So let's look at how that looks. I'm going to call, notice these were all, what they said was that these were all ways of finding ZX. I'm going to go ahead and call this side A. These are all side ZX, and I'm just calling that A. So I put an A right there. So if we were going to find A, we could, let's see, A is the, if we're standing here at angle X, what's A? It's the hypotenuse, right? Because it's opposite the right angle. It's actually always the hypotenuse. That's the hypotenuse. If we're standing here at angle X, this is the opposite, and this is the hypotenuse, right? So I could say that sine of X is 30 over A. Everyone with me so far? I said, we're standing here. This one's opposite, right? Because it's the one that's not attached. I'm sorry. So guys, I'm taking a hiatus from saying things about phones because I'm tired of it. So I'm just going to call parents. I've had it. Anyway, opposite, right? Hypotenuse. That's where I said the sine of X is opposite over hypotenuse. So to solve for A, I got to get A out of the denominator. See how A is in the denominator? And I want A equals something, right? Because we're supposed to be solving for A, also known as side ZX. So see how A is in the denominator? I'm going to multiply both sides by A. Also, to answer this question, definitely not. We can't use Pythagorean theorem if what they're asking is for sine and cosine of the angle. Okay, so, but you're right, you can. If we wanted an actual number, yes. So I'm trying to get A by itself, right? Right now, the A's are canceled, but I got rid of the A in the denominator, but I got to get rid of this sign here. That's why I'm going to divide both sides by sine of X. So I'm left with A is equal to 30 over the sine of X. Now, how that would be handy is if we knew the degrees of it, that's a number with however many digits we want. It's an easy calculation. And also, if the angle was changing, you could just make this change however much whenever the angle changed. That's why they invented this thing, because if you were using Pythagorean theorem, you couldn't adapt so quickly. Okay, so there's one of them. So 30 over sine of X. Oh, you'll notice that's not there. Okay, but if A is 30 over sine of X, it can't be 18 over sine of X, so this one's a no. So what if we were talking about the cosine of X? The cosine of X, we're staying here in X. Which one is adjacent? So cosine is adjacent over hypotenuse. That's the ka of SOHCAHTOA. So there's adjacent over hypotenuse. So that's 18 over A. We're going to do the same trick we did before to get to get A by itself. I'm going to multiply both sides by A, and I'm going to divide both sides by cosine of x. That got the A out of the denominator, got it over here, and got the cosine to the other side. So I get A is equal to 18 over cosine of x. So 18 over cosine of x. So this one's a yes. The others were involving z. Let's see. So if I'm standing here at z, I'm running out of room a little bit. Let me write here. So if I'm standing there at z, the sine of z, what's the sine of z? If I'm standing here, what's opposite me? 18 is, right? So 18 over a. 18 over a. So you might already see the pattern here, but I'm going to go slow here and do it anyway. I'm multiplying both sides by a to get rid of the a in the denominator, and dividing both sides by sine of z to move the sine of z. That gets plain old a, 18 over sine of z. 18 over sine of z, yes. So if I have, so my cosine of z, I'm at z, cosine is 30 over a, right? Because 30 is adjacent over hypotenuse. Yes? 30 over a. You might have also noticed that basically what we're doing is just switching these around. Remember here we started with cosine of x is equal to 18 over a. I can just switch them. See how I just switched them? I'm just going to switch them. $30 over cosine. So this one, and this one all would give you this length.